Welcome to this explainer. Okay, so if you're someone who loves to cut through the noise and get straight to how our world actually works, you are absolutely in the right place. Today, we're diving into something that completely shifts how we think about human knowledge. See, we often picture science as this giant, heavy, dusty textbook full of absolute, unbreakable rules. But what if I told you it isn't a rigid set of laws at all? Instead, it's this ever-changing, totally dynamic, and honestly, incredibly exciting draft. It's an evolving blueprint.
So, let me ask you this. Is science just a static list of facts, or is it an unfinished draft? You know, it's really easy to fall into the trap of thinking that once a major scientific discovery is made, boom, it's locked in stone forever. But that fundamentally misses the whole beauty of the scientific process. The knowledge we have today isn't permanent. It's alive. Literally every time we point a new telescope up at the stars or peer down into a new microscope, we are actively revising and editing our understanding of reality. Section 1. The Scientific Blueprint. When we look back at the history of major scientific theories, the biggest takeaway by far is that science is tentative. It is fundamentally subject to change. Now, I know some people might hear the word tentative and think, wait, does that mean science is unreliable? No way. Absolutely not. This tentative nature is actually science's greatest superpower. It's the built-in mechanism that allows human understanding to grow, to correct itself, and to expand whenever new evidence or superior technology comes along. Basically, we draw a blueprint, and then as we learn more, we grab our pencils and we make that blueprint better.
Okay, moving on to Section 2. Let's look at gravity's first draft. Whenever we talk about how physical matter interacts, we absolutely have to talk about Isaac Newton. His laws of motion and universal gravity were just a massive triumph of the human intellect. He gave us the foundational principles for how objects move and pull on each other, and it was a breathtaking achievement. I mean, it takes some serious brainpower to mathematically explain an apple bonking you on the head, right? But, and here is the crucial part, it was just a first draft. It was a brilliant, world-changing blueprint for sure, but it wasn't the final, complete picture of the universe. It was the starting point for centuries of incredible revisions.
Which brings us to Section 3, Better Tools, Better Science. Let's walk through a sort of timeline of human progress. Back in the 17th century, we get that foundation, Newton's laws. But then leap forward to the 20th century. Suddenly, advanced telescopes are capturing entirely new evidence about how light and mass behave way out in deep space, pushing us toward those massive Einstein revisions of gravity. Fast forward again to today, the 21st century, and we've got satellites in orbit. They provide us with superior technology and measurements so unbelievably precise that they constantly test and refine our models. It's pretty simple. Better tools equal better evidence, and better evidence means we confidently update the blueprint.
And the really cool thing is, this process isn't just limited to physics or gravity. This exact same momentum of investigation and revision has established almost all of our major scientific milestones. Take cell theory, for example. That was a massive shift initiated when early microscopes revealed these tiny little rooms in cork, eventually proving that all living things are made of cells. Or think about plate tectonics, the model of Earth's crust slowly moving and shifting over deep time. These ideas weren't just handed down from the sky. They were drafted, tested, and constantly revised by generations of curious minds looking through better microscopes and using better seismic sensors. Section 4. Who exactly holds the pen?
Ultimately, science is a human narrative that evolves over time. It is not just about cold, hard data, and it certainly isn't some isolated activity happening in a vacuum. The whole discipline of science is deeply, fundamentally human. And because it's human, it totally relies on diverse perspectives, unique problem-solving skills, and the sheer courage of individuals from all genders and from incredibly varied backgrounds. To put it simply, to get the best blueprint, you need the most diverse set of architects.
Just think about Katherine Johnson. Her breathtaking mathematical work at NASA was absolutely critical to drafting our early spaceflight blueprints. Or consider Mario Molina. His vital, groundbreaking research opened our eyes to the depletion of the ozone layer, literally changing how we protect our entire planet. These are brilliant individuals from totally different backgrounds who stepped right up, held the pen, and dramatically expanded our scientific horizons. So when we say science is open to everyone, we really mean it. And this isn't just a nice, feel-good sentiment, it's an absolute historical necessity. If our scientific knowledge is tentative, if it literally requires constant new evidence to grow, then we desperately need anyone and everyone who has the courage to look at the world, ask really difficult questions, and provide that new evidence. Regardless of your background, your gender, or where you come from, you have the potential to be the person who redraws the blueprint of reality. And finally, Section 5.
An unfinished masterpiece.
I want to leave you with this deeply provocative question to chew on. What will tomorrow's technology reveal about today's blueprint? Because everything we think we know right now, all those incredible facts and theories we hold so dear, well, they're just the best draft we have right now. There are entirely new tools being invented this very second, and an entire generation of diverse, brilliant minds getting ready to use them. The story of science is wide open. It is a completely unfinished masterpiece. Thank you so much for joining me to explore this today. Keep questioning, keep learning, and I'll see you in the next explainer.